Hello everyone, welcome to another one of my YouTube videos. In this one, we'll discuss the most misunderstood software concepts. So we'll go through some, common concepts in software engineering or coding that people commonly misunderstand. So let's get right into it. The first one is the single responsibility principle. So when you read this, it sounds like, SRP means that every class should have only one responsibility or only one method. But while this is a good thing, it sounds good, but this is not actually what this principle means or intends to say, right? So SRP means that a class or module should only be responsible towards one thing. Obviously, it encourages you to, have modular design and split out things in separate classes, but it does not necessarily mean that each class should have one method or do only one thing, right? It more means that it should have one reason to change. Like, it should not be responsible to multiple business functions. It should only have one reason to change, right? So for example, if you have a piece of code that, let's say, computes some tax, right? And this tax computation is used for maybe generating some report and maybe also paying employees. So now suddenly your code is responsible for two different things or business functions that could potentially be different in the future, right? So this violates single responsibility, because even if you just have one method or one class that is responsible towards multiple things, so that violates the principle. So basically this is saying that you should only have a software class or module be responsible towards a single thing. That's what this actually means. And a related one that people misconceptualize is dry or do not repeat yourself. So the common misconception is that, any code that looks identical should be deduplicated, right? Like if the code is exactly the same or doing the same, you should kind of, deduplicate that and put it in a common place, right? So in general, this is good. Like, this makes sense, but not always. Not just because the code looks the same doesn't mean that it's actually duplicate, or that you should try to make it common, right? So this is related to SRP, that code is only duplicate if it has the same reasons to change. So if the code looks identical and it has the same reasons to change, that's when the code is actually duplicate, right? So that's when you should consolidate. But if the code looks the same at a certain point in time, but they have different reasons to change, then you should not combine them, because now if one thing changes or requires this code to change, it's going to affect something else that doesn't necessarily need it to change, right? So for example, if you're writing a software that produces a report for the CFA and the CEO, right? So let's say this software produces some kind of report from a data for the CFA and the CEO. The software must keep those reports separate, even if right now maybe they look the same, but since they have different reasons to change, because one report will change as the financial requirements evolve, whereas the other report will change if maybe the operation requirement or whatever the CEO needs, those requirements will influence how the other report changes, right? So even if the reports look the same, the software should have at least a different, two different modules that produce that report. Maybe they can internally reuse some parts of some software parts and, change them as they need to change, but the software should allow that those two reports can diverge, and if the CFA asks for something, it doesn't affect the CEO's report. So that's why even if the report looks the same at a certain point in time, if they have different reasons to change, you should not deduplicate that code. Like, you should keep those codes separate even if they're the same, and that is not really a violation of do not repeat yourself, because remember, for you to be repeating yourself, the code should be identical and it should have the same reasons to change. If it does not have the same reasons to change, it's not identical. So it's okay to repeat yourself in that case. All right, let's move on to the next one, which is inheritance versus composition. So this is an object-oriented principle, and it says that the misconception is that inheritance should always be preferred over composition, and that inheritance and parent classes can be used to reuse code, right? And this is a misconception because inheritance is very good for is a relationships. For example, student is a person, right? So the student class can inherit some fields from the person class because it's also a person. But when you think about business logic, right? Let's say there's a report generator, and that there's like three report generators, and all three report generators have some common code. You should not use a parent class to put in the common code, because then it becomes very hard to test, and there's a lot of coupling between the code, and there's no independence in the code. So in that case, composition is preferred because you can create a separate class that has the common logic and compose the three reports up with that other class for the sharing the common logic, right? So do not put common logic in a parent class. Do not use inheritance for that, because it's not really a relationship. So only use inheritance when you want to model is a relationships and share data fields, but not necessarily business logic. In those cases where you want business logic, prefer composition. All right, next, unit testing. So a misconception is that if you write unit tests, it guarantees bug-free code. And the fact of the matter is, unit tests definitely help you identify defects much earlier in the development process, and they're very important, but they are not enough to guarantee bug-free code, right? You need multiple levels of testing. So let me break it down. So unit testing basically ensures that what the developer wanted the code to do, the code actually does what the developer wanted it to do, right? So if, let's say, I want this code to add two numbers, the unit test makes sure, yes, the code actually adds two numbers. But what if adding two numbers was not the right thing to do, right? So your unit test will pass, but it could still be a bug, right? So that's where integration testing comes in, where, okay, is what the developer wanted the code to do, right? Is that actually what the developer wanted the system to do? So the dev thinks that doing an addition was correct, but when he looks at the end behavior of the whole operation or the API or the service, it produces the wrong result. So that's where integration testing comes in. It's like, hey, it was doing an addition in that class actually correct to achieve the end goal of my service or my API, right? So that's what integration testing does. It says like, okay, here's my input, here's my output. Is it correct? So you could still catch bugs in integration testing, even if all your unit tests pass. Now, even after that, right, let's say the developer thought that, okay, for this API to return this certain response, that satisfies the customer need, right? But he could be wrong. Maybe that doesn't actually satisfy the customer need. Maybe once that API returns that response, when it gets integrated into the UI or the other parts of the system, the customer actually doesn't actually get what they wanted. So that's where system and QA testing comes in, where, okay, what the dev wanted the system to do, does that achieve this overall system's business goals or customer experience goals of why that system was being built? So that's where system testing, QA testing, UAT testing comes into play, right? So all these different levels of testing are validating different things and are making sure that that part is correct, but that part being correct doesn't necessarily mean your software is correct. So all these levels of testing are necessary for high quality software. So the next misconception is about test-driven development. So the misconception is that TDD only involves writing tests after implementing code, or strictly before implementing code, right? So that is a misconception, because the crux of TDD is following a cycle. It's that short cycle of like writing failing tests, implementing code to pass tests, and then once the tests pass, refactoring the code to improve the code design and making sure the tests still pass, right? So you could choose to write the part of the code first and then write the corresponding test, The key thing is that the cycle should be short, right? So as any the code and the testing should go together. You should not write the whole code and then write all the tests. And this also ensures that, like, as like the what's driving your need to write the code is actually a test or a functionality that you know your code should do, right? And this also helps you achieve a high test coverage because you're not just writing code because you think you should be writing it. You're writing code because you know that your code should be doing something which you're codifying in your tests, right? So, and if you follow that mindset, you wouldn't write any code unless you have a test for it, right? And if you want to introduce new code, it forces you to make sure that's tested in some way by introducing a test for it. It doesn't actually matter if you write your code or test first, as long as you're doing it in small cycles. The important thing is to follow a cycle, and that gets the outcome that, really test-driven development is trying to drive. Next topic is CI/CD, or continuous integration, continuous deployment. So some people think, hey, if I just automate my build and deployment, I have CI/CD. No, that's not true. CI/CD is a broader set of practices. Obviously, it needs automation, but automated testing, code review, deployment pipelines, like all of these are important to deliver high quality software, right? So if you're automating your deployment process, that means that your deployment process should be enough to guarantee that what you're deploying is safe, right? So in order to provide that guarantee in an automated manner, that means you need automated testing. You need to have code review verification to make sure someone else is reviewing your code. So you need to have staged deployments, like maybe go to a test stage first, let the code bake, and then go to a production stage, right? So CI/CD is more than just automating your release. It's also making sure that the automated release is actually safe and doesn't leak bugs to customers. So next one is subscribe and share. So the misconception is the analytic guy doesn't need his audience, but the fact is, the success of this channel depends on its audience engagement and satisfaction. So please, if you like this video, like it, subscribe to my channel, share it to your friends who would also benefit from this information, and do let me know in the comments what content you want to see, because I'd love to hear that and make content that you guys like. So with that, I'll see you in the next video. Cheers.